video, we're going to talk about the inelastic collisions lab, in which we're going to collide two carts together, and I'm going to show you how to process your data in various ways. All right, so to begin with, here is the setup. Whoa, we've got one cart here with what's called a picket fence on it. So it's got all these little stripes, right? And those stripes there are going to be very important because what they will do is interrupt the laser which operates on this photo gate here. So see, anytime anything passes in between the beam, you can see that little light on top blinks, right? And those picket fences, or the pickets on the picket fence, because they are dark, are going to interrupt the laser beam. So here we watch it. Whoa, look at it go. There we go, right? Every time it hit one of these from the top row, it interrupts the beam, and you get a little blink. Depending on how high exactly I set the photo gate, I could use it to pick up one of the various rows of lines on the picket fence, but I want the most data possible, so I've set it to go with this top row right here. In this lab, what we're doing is a perfectly inelastic collision, and in order to easily and conveniently measure the velocity of the first cart, which I'm going to be pushing, and the velocity of the system after they collide and stick together because of this Velcro, we've positioned it so that halfway through the photo gate, this one will hit the other one and stick to it. Okay, and now what I'm additionally going to do here is, as you can see, there's this graph over here that's brought up. What I'm additionally going to do is simultaneously run it, and you get to see the graph happen. All right, we're going to try this. I'm going to give the cart a push, and we'll see what we get for a graph. All right, now that graph might not look like much, so let's expand it, and whoo, look at that. Now, if you're not sure what you're seeing, this is a velocity versus time graph. And what you're seeing is the initial velocity of the cart, and then suddenly, wham, it hits the other cart, and it slows way down, and there's the final velocity of the cart. All right, now, what you're going to be doing in the lab is using the information from that graph to determine things like the masses of the individual carts. In this case, I used two equal mass carts, but your data might be for not equal masses. So you may have had two equal mass carts. You may have had one where the heavier one was the one that was pushed, or one where the heavier one was the one that was collided with. So you'll just have to be able to decide that based on using conservation of momentum. All right, now for the graphs, you will actually have a position versus time graph. Let me ignore those other ones. This is the graph that I'd actually like you to use for determining the velocity. The other graph is explicitly velocity versus time, but as you noticed, at least you probably noticed, there was a lot of noise in it. Okay, so you actually want to use a position versus time graph. Now, everything I'm showing you here so far is in Pasco. You're not using Pasco for anything. So for this sort of data, we're actually going to end up processing it in another app on your iPad called Vernier Video Physics. All right, so let me put that up. So the first thing I wanted to look at with regard to actually processing your data is what app you ought to be using, and it's this one, Vernier Graphical Analysis GW. There's two available for your iPad, and apparently the GW app works a lot better. That just seems to be the sort of quirk of the iPad. Okay. Now, I actually have the other one installed on my iPad, and it seems to work just fine for me. But if you're having trouble with the next few steps, you definitely need to download this one. And if you don't have any version of it downloaded, then go ahead and start off with this one. The next important step, of course, is opening your data. So I sent an email to you and shared the data with you perhaps, or maybe you got it some other way. However it happened, the data is going to be in the form of a .csv file, likely in the Google Drive or some other format. If it's in your email, fine, so be it. Let me go ahead and pick a run here, which it's unlikely anyone else will use. I'll take this last one, number 20. I poke the 3 dots and open in, and hopefully copy to graphical comes up there, or open in graphical, however it says for you. So for me, boom, it was right there. I could just open it up, and so now the data is in graphical analysis. All right, now if it's not showing up, there are some other workarounds for getting it to go there. For example, you could try emailing the data to yourself, see if it will open from email. Most of the troubles I've had, though, with people being unable to open it is they're using the wrong version of graphical analysis. So for me, regular graphical works just fine, but for other people, you need the GW, which stands for Go Wireless. So try getting the correct version first, and if that doesn't fix it, then we can talk. Okay, next thing is I poke the axes. I did that by poking it with my finger, and then I select, for the x-axis, you always want it to be time. Please make sure it says time on the bottom. If it says something else, then there are problems there. All right, and then for the y-axis, I'm actually going to have you make 2 different graphs. One's position and one is speed. All right, so then I poke that one and unpoke. All right, next bit, and this is probably my graphical analysis, unfortunately, is going to crash because my iPad is old and derpy, okay? But what you should do is try to highlight the data. I won't even try it by actually doing it on my iPad. So, you would poke here and then drag your finger over and select these, in this case, like 8 dots. 1, 2, 3, 8 dots. And the slope of this, since this is a position versus time graph, would correspond to the velocity of the cart before it hit the second cart. So this is the velocity of the first cart, slope of that line. All right, now you can see clearly at this moment, or somewhere in between here and there, that's when the carts collided. And so the slope is suddenly and dramatically different. The slope of this second grouping of dots, I guess looks like 6 dots, is going to correspond to the velocity of the system after the collision. All right, now if you're like me and you have a crashy iPad, then you'll, instead of inserting those trend lines, you'll have to change the axis over here to speed versus time. And I don't like using the speed versus time graphs as well. The reason being that you get noise like this, right? So it's kind of hard to look at it and be like, oh, I think the velocity is number. Now, in this case, we got nice, easy, values here, right? The initial velocity looks to be pretty much exactly 0.46 for this particular run. Right, those data points all agree with that. But after the collision, right, it's kind of up and down, and it becomes a little bit hard to determine what the final speed actually was, which is why using a trend line is probably more desirable. All right, so if your app is not crashing, again, highlight those first whatever number of data points, and then poke this down here, and it will allow you to insert a trend line for that particular bit. And then you could also, and then you must highlight the second grouping of data points. Same idea, poke that. It'll insert a trend line for those data points, and the slope of that will be the velocity of the carts after the collision. Okay, so all of that is stuff that's going to happen in Vernier graphical analysis. Once you've got your trend lines and everything, then what you will do is take a screenshot. Ta-da! And then you have the graph, and you can insert it into the Google Doc, which is going to be, the lab report that you are submitting for this. Please make sure when you submit it that it is of a reasonable size and that you have added to this graph a title. And in this case, it looks like it's kindly giving you position and meters and everything else. So you don't need to label the axes probably, but you're definitely going to need to add a title and make sure that it's big enough to be quite legible. Okay, I think everything else from there is just going to be a matter of following the directions in your lab handout, which might look something like this right here. Okay, all right, fine. And then it tells you all the things that you're supposed to do with that. So once you've got your graphs, you can go ahead and start crunching the numbers and answering questions and writing a lab report. All right, I hope this was helpful, but if you have any questions about exactly what you're supposed to do with the information, please go ahead and send me an email, and I will be glad to help you with any part of this lab activity. Thanks for watching, guys.